Hey, Mr. Chang here. I'm going to show you how to calculate slope. We're going to do it a couple of ways. And we're going to work on D7M in iXL. D7M in iXL. That is going to be our the set of examples that we use. So how I'm going to show you to calculate slope. Follow along in D7M and get that hundo. Should be totally doable for all of you. So here we go. I'm going to kind of put right here on the side one set of strategies for calculating the slope. This is by constructing triangles. And let's take a look at this problem that we got in iXL. Again, we are looking at D7M. D7M. So here we are, D7M. All right, look at this graph. What is the slope? Remember, the slope is the steepness in a direction of a line. So steepness means, how close to vertical it is, how close it is to the y-axis. So these lines are all steeper than this one. This line is flatter and less steep. So that is steepness. And then direction of the line. You can see that this line is ascending. It's going up. That means the y values are going higher as the x values increase. So it is ascending. This direction is up. If I had a line that was like this, then that direction is downwards. And this has a negative slope because you can see that the y values, 4, 3, 2, 1, they're going down as x increases. So this is a negative slope. This is the opposite direction. So when you see this, slope is the steepness and direction of a line. That's what I'm talking about. All right. Let's move on. So let's actually calculate the slope. Here's the first strategy I'm going to show you. When you've got a nice grid, a nice coordinate plane behind your line, one way to do that is to find 2 points where the line intersects the grid lines behind it. So that's where this black line intersects the gray grid lines behind it. So there's a point here where that happens. There's a point there where it happens, where the black line intersects 2 of these grid lines going like this, right? So it makes a perfect cross, the 2 gray grid lines. So I'm just going to put points every place I see the black line intersecting the gray grid lines behind it. That is step 1. Now, step 2, and I'll use yellow since this is yellow. It says construct a right triangle to show the vertical and horizontal change between the points. So I can take any of these points on the line, any of the 4 points that I have here in blue, and I'm just going to draw a triangle. And it doesn't matter. You can draw the triangle below. Or you can draw it above. It doesn't really matter, but I like doing it below. So I'm going to use a red line for the vertical change, and then I'm going to use a green line for the horizontal. And I want to stay right on the gray grid lines, and I want them to intersect. And I'm constructing a right triangle to show the vertical and horizontal change between any 2 points. And so this is a right triangle because I know there's a 90-degree angle in there. That's what that box means. So you can make your triangle any size, but it really, if you're going to use this method, it works to connect the points where all the grid lines intersect so that you can count whole squares. You can count the whole gray grid line squares behind your triangle. So step 3, count the grid squares and write slope as a ratio of vertical change to horizontal change. Did I spell horizontal wrong? I did. This should be, there should be an I right there. Anyways, so this first triangle that I have, I can see that I have 1, 2, 3 boxes, squares underneath. And the second bigger triangle I have 1, 2, 3, 4, 5, 6 underneath. And my vertical change is, for this small triangle, I have 1 box. And then for the big triangle, I have 2 boxes. So slope is the ratio of vertical change over horizontal change. For each point on the line, right, any one of these blue points, how many boxes vertically do I need to go? And how many boxes horizontally do I need to go to get to the next point on the line? That's what slope is. It is vertical to horizontal. It is the ratio of the vertical change to the horizontal change, right? So if I go down 1, and then if I go to the left 3 boxes, I get to the next point, okay? So my slope is 1/3. If I look at this big triangle where I have a slope of 2/6, right? That's vertical, 1, 2 boxes, and then horizontal is 1, 2, 3, 4, 5, 6 across. I can see that this also just simplifies to 1/3, right? Divide both of these by 2 is the common factor. And so the slope is 1/3, and it is clearly the same, no matter how, doesn't matter which 2 points I pick. I can use the big triangle or the small triangle, but either way, I get a slope of 1/3. I'm gonna put that in there. And I've got the slope of 1/3. There you go. That's what, remember, you gotta simplify your answer. Yay, I got 20 points. Just like that, I got 20 points. Let me clear this. Well, let's do this one more time again. I'm gonna use the same method where I'm just gonna construct right triangles. Let me bring my little sticker back. Here we go. Step 1, find 2 points where the line intersects the gray grid lines behind it. I'll use a little blue pen. I'm gonna do this in blue. This is step 1. I've got one at the intercept, 0, 6. I've got one here at 4, 7. I've got another one here at 8, 8. Now I'm gonna do steps 2 and 3 together. Construct a right triangle, show the vertical and horizontal change between points. So I'm gonna use red for the vertical change. And I'm just gonna pick this first point here. So that's vertical change of 1. And I'm gonna use green, and I've got 4, a horizontal change of 4. So there is my slope. And again, the slope, the steepness of this line is 1/4. That means every point on this line, right? You see these little blue dots? Every point on this line is a ratio of 1 up to 4 across. 1 up, that's 1, and then 4 across. 1, 2, 3, 4. 1 to 4, vertical to horizontal. That is my slope. Every point is some ratio of 1 to 4. So if I even pick like a point that's like on this line that is super close by, like these two, and I drew a little triangle between them, it would probably be some fraction like it'd be like 0.01 to 0.054 squares. But if I simplify that, that's still going to be 1/4, a ratio of 1/4. So for every point, any point on the line, this works. So I'm just going to enter in my slope. And remember, I forgot to really just talk about step 4. So step 4 is to simplify your answer. 1/4 is pretty simple already, but it could have been, again, 0.01 over 0.04. It could have been, if I made a big triangle here that was, let's say I picked these 2 points and I went 8 boxes across and 2 boxes down like this. So that's 2, and then this would be 8. Then I would have to simplify my answer, and 2/8 simplifies to 1/4. They're equivalent ratios because there's a common factor of 2, divide out the 2, and I'm left with 1/4. All right, so I'm going to enter in my answer once again. What is the slope? My slope is 1/4. I'm at a 36. As you know, if we're grading this, you just did 2 questions and you're kind of at a C already. But let's keep going. Now I'm going to show you a different way to calculate slope. You're going to actually use the formula, the slope formula. And the reason why you want to be able to use the slope formula, you want to have this memorized, because sometimes it's hard to count the boxes, and it's you know, you make little mistakes here and there. You can't tell if the lines exactly cross each other. So here's another way to do it. Okay, 4 steps again. Step 1, write the coordinates of 2 points where the line intersects the grid lines behind it. So we're going to use coordinates to do this. So I'm going to pick a point here. There's a clear point of intersection there. Whoops, let me get my sticker back. There's a clear point of intersection there. There's a clear point of intersection there. There's a clear point of intersection there. But let me just choose this one. So this is 7, 0. Okay, remember, it's always x, y when you're doing coordinates. 7 across on the x, 0 on the y. And then my next point is at 8, 2. 8, 2. So step 1, taken care of. I wrote the coordinates of 2 points where the line intersects the grid lines behind it. And I'll call this point 1. And I'll call this point 2, P2. Now I've got to use this formula. y2 minus y1 divided by x2 minus x1. That is the formula for finding the slope from coordinates. Remember, the little m is what we use in math to represent the slope. Now, y2 minus y1, those are the y coordinates of your 2 points. So this is the y coordinate of point 2. So that is this one right here. This is y2. And then y1 is the y coordinate of point 1. So this is y1, 0. So if I'm going to use this formula, I'm going to have the y coordinate of point 2 minus the y coordinate of point 1, which is 0. So my numerator is 2 minus 0. And then I'm going to go down here and I'm going to look for my x coordinate of point 2 and my x coordinate of point 1. So this little number, again, refers to which point you're talking about. So my x coordinate of point 2 is 8. And my x coordinate of point 1 is 7. And I've got 8 minus 7 underneath. So now it's just really simple math. My denominator is the number 1. My numerator, 2 minus 0, is 2. Now we're going to simplify this because 2 over 1 is just 2 wholes. So if you simplify this, your slope is 2. All right, so we've used the slope formula. We simplified the answer. A couple of things to keep track of. The reason why you have these y2, y1, x2, x1 is because you need to keep the order the same. Keep the same order for subtraction in the numerator and denominator. So if I'm subtracting 0 from 2, right, 2 minus 0 at the top, then I have to go 8 minus 7 on the bottom for the denominator, for the x coordinates. I cannot flip these two around because then it won't match what you did at the top and you will get the wrong answer. So make sure you keep the order the same, and that's what the little 2 and the little 1 help you do. It helps you keep the order straight. Keep track of negatives. We'll get to that in a second. So we've got our slope. Our slope is 2. It's also m is 2. One more thing that I'll just sort of highlight for you. When you're subtracting two y coordinates from each other, what you're really doing is coming up with the vertical change. So I'm going to draw a little red line. So you see that 2 minus 0, that means 2 right here. And then 8 minus 7 gets you 1. So your horizontal change is just 1 square. So this formula basically is just a fast way to help you draw those triangles. When you subtract two x's, that's the horizontal change. And then when you subtract your y coordinates, that's really your vertical change. So this is just the same as drawing those triangles, right? Y coordinates go up and down, x coordinates go back and forth. So there you go. Let's see what my grade's at now. I'm going to put a 2 in here. I'm at a 50. All right, I want to get, my next mark is to get to an 80. Let's clear this out. Oh, now this is interesting because they've changed the, units on the graph. So I know I'm going to have to simplify this a lot. So I'm going to use my 4-step formula here. So I'm going to identify a couple of points. There's a point there. There's a point there. Again, this is where the black line is intersecting with the two gray grid lines behind it. And I will take my first point as this is 80 on the x and 20 on the y. So this is 80, comma 20. And I'll make that 0.1. And then my next point is 90, comma 40. And I'll make that 0.2. Okay, so I've got my coordinates of 2 points, and I wrote the coordinates down. 90, comma 40, that's 0.2. 80, comma 20. I'm using these 2 points here. Make them really big. Now I'm going to use my formula. So I've got to identify y2 and y1. I'll use red to do that. So this is y2 and y1. Remember, that's the y coordinate of 0.2 and the y coordinate of 0.1. Then I'm going to use green to show you the x coordinate of 0.2, right? X coordinate of 0.2, and then I'm going to use green, and this is the x coordinate of 0.1. I've got everything labeled. I can use this formula pretty easily now. I'm going to subtract y2 from y1, and I'll write this over here. So my vertical change is 40 minus 20. And my horizontal change is x2 is 90 minus 80. Okay, so the math should be pretty quick here. 40 minus 20 is 20. 90 minus 80 is 10. There we go. That's my slope, 20 over 10. Now let's do step 3. Let's simplify this. So my slope is 20 over 10. I know that 10 is a common factor for both of these numbers. So if I take the 10, if I divide 10 out of both the numerator and the denominator, I'm left with 2 over 1. 10 goes into 20 2 times, and it goes into 10, it goes into itself just once. So there's my slope, 2 over 1, which I will simplify one more time to just 2, positive 2, just like the last one, positive 2. So I kept the same order for my subtraction in the numerator and denominator, subtracted y2 or y1 from y2 and x1 from x2. I still don't have any negatives yet, so nothing to worry about there. And I simplified it, so I'm good. I'm just going to enter in the number 2. And just to show you, by the way, again, the vertical versus the horizontal change, we basically just counted 1 box, 2 boxes. So there's my vertical change, and then 1 box to the right, there's my triangle. Each triangle represents 10, so that's 10. 2 boxes is 20, so that's 10 to 30, 30 to 40, so that's 20 on the vertical. So 20 over 10, that's what I got for my slope. Enter in the number 2. Away we go. Bam. Look at that. Now I'm at a 60. All right, you guys. There's a 20-minute video on slope. This is D7M. You guys should, if you got this far, take it all the way. Get an 80, get a hundo, lock that hundo in, because D7M actually is all positive slopes. You don't have to worry about negative numbers. This is a good place to get an A. All right, Chang out.